All right. Working with data, day 2. So we looked at some nice metrics or measurements used to sort of summarize a whole bunch of data with just one or two numbers. Mainly, where's the middle, the center of the data, mean, median, or mode, and how spread out the data is, which really is range and standard deviation, although variance is technically there. We just don't really use it except to get the standard deviation. So for graphing, the graphs are pretty straightforward, the styles that we use, but we do need a little bit of thought put into what type of graph makes the most sense for the data. And that can depend on a few different factors, including what type of data we're working with. For example, we have two types that we are thinking of here, so qualitative and quantitative. So qualitative is a quality. So that's not something you can measure or count. That's like color or favorite movie or things like that, not a number. Whereas quantitative is a number, but that gets divided even further. So quantitative means number because it's like quantities, amounts of things. So there's discrete data, and discrete just means things that are counted. They're only whole numbers. So how many cars in a parking lot? There should not be 3.615 cars in the parking lot, right? There's one or two or three or four and so on. So if you can count it, it's discrete. If it's something you can't count, you have to measure, like your height, your weight, that kind of thing. That's called continuous data. And we display the different types of data differently depending on what our need is and how they behave. So when we're doing a graphing, qualitative, you're just counting it, right? Like you're just counting how many people fall into each category, really. So it ends up basically being like a type of discrete data. You're measuring what people's choices are, but then you're counting how many pick each thing. So these two are very closely related, and we use the same type of graphs for them 99% of the time. Sometimes if discrete data is, there's too much of it, we do it a different way. But in general, qualitative, discrete data, they function the same, and we'll use certain ways to graph it. Continuous, or ones that are just there's a ton of data, we can graph a slightly different way, and we'll show those in a minute. So qualitative, again, categories. Gender identity, why you didn't come into work, what type of car you drive, what's your eye color. Discrete, things you can count. How many toppings do you get on your pizza? How many siblings do you have? What year were you born? What was the score of the hockey game? Things like that. And then continuous. Again, so it's things you have to measure. So like how far do you have to walk to school? How tall are you? What's your grade point average? But also could be just, we can put really large numbers into this category. It's not technically continuous, but we treat it that way because if you were tracking how many visitors went to a theme park on every given day and you're getting numbers in the thousands and tens of thousands, we can't do a nice little bar graph that has one little category for every single possible number of people. There's just way too many. So functionally, we put that into the continuous category just for how we're going to manage the data. So how do we display one variable data? Well, we basically have three options. We've got pie graphs, which we've seen before, cuts everything, it makes a circle for the whole thing and cuts it into pieces. So these work really well for anything where we have a frequency. So those are great for qualitative graphs. But the big value, what is it for, is when we want to compare a category to the overall total or to the whole amount. So pie graphs are great when you want to compare each category to the whole. So, I mean, we can really quickly see that this, ooh, getting auto formatting here, that this nice blue category is like a third of the data. Like it uses up about a third of it. Even if we didn't have the percentages there, we could see how it compares to the rest. We can see that these two categories are relatively small compared to the other ones, right? So if you want to compare categories to each other, this is the way to do it. The bar graphs, these are specifically for things that are countable. So qualitative or discrete, either one is fine. And its purpose is to compare the categories to each other. So in the pie graph, it's really easy to compare how much of the whole pie each one takes up. But it's a little harder to compare how they relate to each other. The bar graph is really easy to see, like, it looks like the yellow here is about double the purple kind of thing, and how they sort of react, how they relate to each other. And that's the main purpose of the bar graph, is when we want to compare one category to the other. We don't care necessarily how much of the whole thing they use up, but just how they relate to each other. So I'm going to get rid of this part up here. I don't like that. I've changed my mind. We're not going to worry about that kind of stuff. But you will see that these are primarily the qualitative and discrete graphs. And this histogram is for continuous. So what makes this one continuous? Well, you see with these first two, they are like separate categories, right? They are individual categories. You have to be in one category or another. In the continuous, there's no gaps between the bars, right? Every number is represented somewhere here. So what the histogram does is, rather than having these completely separate categories, it's going to take your measurements or your giant sum of number, and it's going to then group them into categories as part of the process. And then you can kind of compare these ranges. So these first ones are specific categories. These two are categories, whereas this one deals more with ranges. Sorry about that. So this is for the continuous graphs. This is for comparing ranges of continuous data. So that's what they're for. We are not going to make pie graphs by hand. That's no fun. It's a waste of your time. We are going to make a bar graph by hand. We're going to make a histogram by hand. It has a few extra steps that are kind of annoying. And then we're going to look at how to make all of these in Google Sheets. So that's the plan for today. So to make a bar graph or a histogram, the important thing for the graphing, for the y-axis, it always has to start at 0 on the y-axis. The x-axis does not have to start at 0, but the y-axis has to start at 0. If you don't, you can run into this situation where you're being deceptive with your values. We'll talk about this later, but the idea is essentially if you had like a bar graph, kind of like this, that doesn't have very major changes. And then if you were to not start at 0 and start like here, then suddenly the gap from here to here looks huge. It looks like it went up by like 10 times or something, whereas it didn't even quite double. So that's a big no-no. So your y-axis has to start at 0 so we don't accidentally lie with statistics. You only go as high as you need to. You need to use as much of the graph as you possibly can, like always, and the numbers are on the lines. Easy peasy. And then we have to label everything. So make sure you label your x-axis, your y-axis, and give the graph a title. So that's the same for both. The x-axis is going to behave a little bit differently. So let's start with a bar graph, because bar graphs are simpler. So we need to figure out how wide to make the bars, how much we can space them out, right? So we're going to need a bar for each category, and then you're going to need a space between each category. So if you effectively need twice as many kind of categories when you're figuring out how wide you can make them, then you would need, because you need, for every category, there's a space, and then a category, and then a space. So you need to think about like fitting twice as many in. All the bars have to be the same width and evenly spaced. Each bar should have a category label underneath it. And ideally, you color and shade them all differently so it's easier to read. So we've got an example here. How many grade 3 students, how they get to school. So we have a little tally table here, and it's easier to come up with totals that are numbers. So how many walk? Well, 5, 10, 13. How many ride the bus? 5 plus 2 is 7. They take a car is 4. They ride their bike is 5, and they take the train is 1. So that's how they get to school. Let's make our graph. Yeah, we can do that first. So what variable are we measuring? Because this is a single variable question. What are we measuring? Well, we are measuring how many people use each form of transportation, right? How do people get to school? That's our one variable. How do they get to school? Now let's make it a graph. So our y-axis has to start at 0. Has to start at 0 no matter what. And we have to get up to a total of 13 because 13 people walk. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, we only have space to get there once, so we're counting by ones. I don't want to label every single one, so I'll skip 1 every time. 2, 4, 6, 8, 10, 12, 14. There's my y-axis. Easy peasy. And we are counting, so this is a frequency. How often it happens. And then my x-axis. Now here's the bit of work. So how many categories do I have? I have 1, 2, 3, 4, 5. So that means I'm going to have these gaps in between too, right? So realistically, I have to deal with 9 different things for when I'm spacing it. 1 gap in between each. If you want to, you can just double it for shorthand, but either way works. So how many times can I get to 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so each one can be 2 wide, and we'll have a little gap at the start. So there's my first category, and then I leave a space in my second category, leave a space, third category, space, fourth category, space, fifth category. And we label all these categories. I'm just going to use single letters for now, or double letters. So this is walking, bus, car, bike, and train. So there's my categories. For my axis label, mode of transportation or how they get to school, anything descriptive about how it works. And then we make the bars. So in this case, the height of each bar is going to be the frequency. So I have 13 people walk to school. So you need to go all the way up to 13, and you should use a ruler. If this is an assignment or something and you don't use a ruler, I'm going to take marks because I'm picky that way. This program doesn't have a great ruler, but that's what we'll do. And then busing. Busing was 7. So bus goes up to 7. And then 451. Car is 4. Bike is 5. And train is just 1. So that's how you do it. And then you should color in every bar its own color, or at the very least use its own kind of hatching scheme so they all are distinct. Something like that. Perfect. And that's how you make a bar graph. That's it. I guess we'd have our title up here. How grade 3 students get to school. That's it. Perfect 10 out of 10 graph, except with rulers. So that's it. Histogram are a little bit more complicated. So for our x-axis for these, we first need to find categories to break the data into. So it's continuous, right? It's any possible number. So I need to break that number into groups. So to do that, number 1, we find the range. Number 2, we divide the range by 5, and we divide it by 10, and we pick a nice integer between those two values. So a nice whole number. And that will be our category width. Okay? And then I'll write down what all my categories are. And this will make more sense when we do it. And then we basically turn it into a frequency table. So we're going to have our categories that we make, and then we'll count how many fit into each category. Since it's continuous, there's a line on the edge of the category that's technically a part of both. It goes in the bigger one. If a value is right on that line, it goes into the higher interval, the bigger one. And that's about it. So you'll start with a number that's a multiple of the interval size, and you'll work from there. So let's see what it looks like. Sorry, I need a little drink of water here. So when someone has a stroke, it's often has a neurological impact that takes a while to recover from. So you'll be in rehab learning how to use your motor skills, how to talk again, all that sort of things, and it can take a range of time. So they did a sample of 30 patients, and these were how many weeks they needed to be in therapy before they could kind of get back to functioning fairly well. So the quickest was 1. One person only needed 1 week of therapy, and then they were right back to it. On the other end of the spectrum, one person took 22 days, or 22 weeks before they were back to functioning. So the range is just the maximum minus the minimum, which is 21. So that's step 1. Find the range. Step 2, we find our interval size. So we're going to take that range, 21, and we're going to divide it by 10. and we're going to divide it by 5. Why? Well, doing divided by 10 will say how wide would each interval be if there were 10 categories. Dividing by 5 is how wide would each interval be if we wanted 5 categories. And since we want between 5 and 10 categories, if we pick a number that's between this value and this value, we will have between 5 and 10 categories, which is what we want. So that's the idea here. So if we divide by 10, we get 2.1. If we divide by 5, we get 4.2. So we can pick any number between 2.1 and 4.2. So we could pick 3 or 4 for a category width. A lot of the time, the more categories you have, the better the detail. So we'll pick the smaller one. So our interval size is 3. So that's step 2. We now know our interval size. Now we need to make our intervals, our categories. So it has to start with a multiple of the interval, and our lowest is 1. So the only thing that is a multiple of 3 that's smaller than 1 is 0. So this will be the category that goes from 0 to 3. And then we'll have a category that goes from 3 to 6, 6 to 9, and so forth until we get to where we need to be. So there are my categories. And now we just count them up. Count up how many fall into each category. I like to kind of do ticks as I go. So for 0 to 3, there's 1, 2. I don't count 3, right? Anything that's right on the edge will go into the higher category. So I'm only counting 0s, 1s, and 2s in this one. So there's 1, 2, and that's it. I have a frequency of 2. So go through the rest of the table, pause the video here for a minute, and then when you have everything counted and sorted, unpause and we'll continue on. So there we go. I'll count it up, and it's good to just do a double check and do a total, make sure they add up to 30, which is how many we started with, just to be sure. At this point, it's basically like a bar graph again. Especially the y-axis. Y-axis works exactly the same way. It's just going to be the frequency. So we need to go up to a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can count to 9 twice. So I'm counting by 2s. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that's the frequency. And now for the x-axis, we think in terms of categories. So I've got 1, 2, 3, 4, 5, 6, 7, 8 categories. So I'm going to break it up into 8. So I know this is 20 across. I can count to 8 twice. So each category will take up 2 squares. And I start right here, not necessarily at 0, but at the start of the first category. In this case, it is 0, but the x-axis doesn't have to start at 0. So it'll go 0 to 3, 3 to 6, 6 to 9, 12, 15, 18, 21, 24. Okay? And that's my weeks of physiotherapy on this axis. And then just like the bar graph, we use the height is the frequency. So 0 to 3 was 2. So we have a height of 2 on that one. 3 to 6 has a height of 5. 6 to 9, 7. 9 to 12, there are 9. And then 12 to 15, only 2. 3 for 15 to 18. None for 18 to 21. And then 2 ooh, I don't know what's happening now. Let's try that again. For 21 to 24. And just like the bar graphs, we should try and have some different colors or hatching on these so you can tell the bars apart a little more easily. Just so they stand out a little bit better. That one's kind of blending in there, so let's color it into. Okay. So there's the graph. And up here, recovery times after stroke. And hopefully you can see how much more meaningful this graph is than just this list of 30 numbers. If somebody asked me what's important, what's meaningful here, I get nothing, right? We could do mean, median, or mode to come up with a good estimate. And I'd add a little bit of meaning, right? What's the average? But this is so much clearer, right? We can easily say most people take between 6 and 12 weeks, right? There's some that take a lot longer, but it's a lot rare. It's not very common to take more than 18 weeks, things like that. And we can kind of estimate where the middle of the data would be. It's probably somewhere around this 12-week period. We can see there are some slight outliers over here that might skew the mean a little bit. So maybe median would be a better measure of center here, that kind of stuff. So that's the idea of why we want to make it visual, and that's how to do the histogram. You will need to know how to do that for the test. So now we're going to move to Google Sheets. So Google Sheets are a lot better, really, in the end of the day, because they can do the work for you. They're kind of ugly. The sheets are kind of ugly. I like Excel better personally, but can't run Excel on a Chromebook. So here we are. So if we were to do this in Google Sheets, you'd type it out just like this. And this spreadsheet is already available on Google Classroom. So if you need to pause this, get that open so you can follow along. And we'll continue from there. Here, I'll just fix the alignment there a little bit. Okay, so how do we turn this into a chart? Well, for pie graphs or anything else, you can select the first column you want, your categories, and then select the frequencies. And then up here, this button here says Insert Chart, and you just click it. Or you can go up here and insert chart from the menu. I like the button. So Insert Chart. There we go. We have a chart. We did it. Now, if I wanted a pie graph, this isn't great, but here's a nice bar graph, or as Sheets call it, a column chart. You'll see it opens up this chart editor that lets you control all the properties of it. If it doesn't, you can double click, or you can select your table and click these three dots and then say edit. And this is really how you control everything in it. So if I want a pie chart, I'm going to click this and change it to a pie chart. And you can do a full pie chart, a hollow pie chart. You can do a 3D pie chart, very fancy, and all kinds of things like that. And then you can make all sorts of modifications on here if you want to. So in the customize, let's look in here. We've got background colors you can change if you wanted to kind of make it a little more pleasing to look at or not quite as bright. Border color, whatever you want. Make it bigger. You can take off the 3D so it's a normal one. You can change the font, all that stuff. In the pie chart one, if you want to turn it into a donut, you just select how much of it to be empty. You can put the labels on the slices themselves or the values of them, or it can even calculate percentages to show what percentage of each one. Again, labels, you can bold, italics, all that. You can infect individual pieces. So you can say I really wanted to focus on which one, how many are taking the car, and we can pop that out of the pie to draw attention to it if we want to. The labels, you can show you change the title. And the legend, if you want the legend like this here, if it doesn't show it, you can turn it on. You can auto, you can pick where you want it to be, all that kind of stuff, and play with the settings. So every chart has slightly different options to play with inside of all this customize, but that lets you really play around with it. So that's how the chart works. Let's go on to the second tab when we have more continuous or varied data. So here's our weeks of rehab again that we made by hand. And we're going to, we're just going to take a quick look at this. This one, you only have one category. So you take the category, you select it all, including the title, you make your chart, and it tries to make it a line chart, but we're going to choose histogram, or if it's not up there, you can go way down to the bottom, it's in other, the histogram, and it'll break it into categories for you. So this one made it so there's only the 5. And then in the customize, you can play with the bucket sizes. So we did 3, right? So we could force this to use a width of 3, I believe. And then it'll actually match up with the one we made, and you can play with everything else. So for the examples, I want you to go through that, make them look like the tables. That's good practice. And then practice problems to make sure we're ready for next week. This will be a key skill at the end of stats. We will be having a big stats project. You are going to have to create graphs and interpret them and all that. So take the time to really play around with the options in here and see what they all do. Playing around a little bit's the best way to get comfortable, and then it makes it so much easier later on. All right, that's it for today.